Hey, hello everyone, and I welcome you all to Rankplus JEE English. In today's video, we are going to cover a very important topic, which is semiconductor. It's important for your board exam as well as for your JEE exams. And if you will see the JEE actual paper, you will find that at least 2 or 3 questions will be coming from this chapter only. This is very important lecture, and you do not have to miss any topic. In this lecture, I'll be covering these many topics, which is as per JEE Main 2025 syllabus. So I have segregated this topic, semiconductor, into 6 equal parts. And the most important part is logic gate, which will come in the last section of this video. So do not skip this video, because every part have some specific weightage and the important concept for this logic gate. So this lecture going to be very useful for your JEE 2025 exam. And also, I'll be covering the complete theory plus a bonus. What you are getting in this video is I am also going to discuss the previous year questions from JEE 2024 from January and April attempt. So this will be a bonus for you. Okay, so in this video, I'll be covering these things, theory plus PYQs from January and April attempt. So I'll be testing you on the real questions from the real paper of JEE 2024. So it's going to be a very knowledgeable session for you. So do not miss, and please do share this session with your friends so that they also get benefited from this session. And also, before we proceed, you have to join our Telegram group. The link is in the description as well as in the live chat, which is there. I think that it's pin. Yes, the pin chat. Or you can go to the Telegram, type IIT JEE Rankplus English. You will get our Telegram group. This Telegram group is very important because you will be getting the PDF there, whatever I'm going to teach you. So let's start this session. As I told you that I have to discuss each and every concept which I showed you here, that we will start with what is semiconductor, why semiconductor is required. And as you know that I am an electrical engineer, so I have studied all these semiconductors in 4 years. So I'll be taking to a next level, you will think, right? So semiconductor, we will do semiconductor diodes, IV characteristics, forward and reverse, what will happen. So even if you are giving your board exam this time, this lecture going to be very useful for you, okay? Because each and every part we will be covering. And a bonus other than this, these are what we are doing here. But just after the session, you will be getting a practice sheet from me, a special practice sheet designed specifically after analyzing the complete JEE Mains PYQs of at least 3 years. Okay, and also you'll be getting a highlighted NCRT that will be very helpful to score more marks and to get the correct theory. Okay, so let's start the session with a very basic thing, that what we are going to study in this topic. So please light up the chat. Please mark your attendance in the chat. Are you all ready, my working hard Harshat, Bala? Are you all ready? Let Shall we start our session? Shall we start? Okay, let me start. As you all know, I'm starting from a very basic thing. If you see this universe, you'll be finding a lot of matter around us. And if you find out that matter is actually made up of atoms, and atoms are made up of subatomic particles, and subatomic particles, we are considering only 3 subatomic particles which are there in our syllabus, that is electrons, protons, and neutrons. This electron is very special because it's a mobile charge type in an atom, which can move from one atom to the another atom. So this is electron, proton, and the third one is the neutron. Neutron do not have any charge, and also it's in the nucleus, so it doesn't move anywhere. So we know that charge we have already discussed in the electric charges and field. So charge is basically a special property of a matter due to which it can create and experience the electric and magnetic forces, right? So we know that if charge starts to flow, if charge starts to move, there is current, right? If charge starts to move, there is current. If charge is at rest, there are so many phenomena which we have already been discussed in the electric charges in the field. Like the charge will be having the electric field, and due to that electric field, there will be, if there is another charge, it can experience a force. There can be potential. There can be something other things. Right? There are so many things which we have studied in the electric charges and field chapter. But here, what is the main concern for us is that when charge starts to move, there will be a current, right? We all know that is the electric current. But can we control that electric current? Can we control? Can we control the flow of electron? The question was that once we have discovered that due to the flow of charges, there is current, but the question rises, can we control the flow of electrons? Or can we control the flow of charge? Specifically, if I'll have to ask to something, can I control the flow of charge? In conductor, it's very difficult to control, because if I'm having a copper wire and if I'm providing a voltage to it, there are so many you will see that there are so many electrons out there which is free to move, and the moment you provide the potential energy, they all getting started to get the velocity, right? You will not be able to control them. It's like if you are in a class and there will be so many students out there, and they are shouting, right? So if they are shouting, then you cannot control them. The monitor cannot control. Like teacher, principal, they can control, but the monitor cannot control, right? So similarly, in a conductor, we cannot control the flow of charge. So we must require some other materials where we can do that thing, right? So engineers were very curious, scientists were very curious that is there any material where we can control the amount of charge which can flow per second? So they got they got vacuum tubes, right? Let's see the history behind that. The history started with a vacuum tube. And if you have studied a computers in your school life, you must have studied one chapter which is dedicated to the generations of computer. In those generations of computer, you may have seen this thing that vacuum tube were used in the generation 1 computers. Have you ever gone through that topic? That by using the vacuum tube, actually we can create or we can control the flow of charges. And after that vacuum tube used in generation 1 computers, actually they were very bulky. They were very bulky. The size was very large, very big, or you would say a bulky thing. And also, they consume high electricity. They consume high electricity. Now the question is, if we found out the problem, we always have the solution. If you know that what is your problem, you can easily find out the solution. But the problem is that sometimes we do not even know about that what is the problem. if you are not scoring well, you must know that what you need to do. But you are not able to do that. You are not able to go through the plan which you have in your mind. So you must require a teacher who can hold your hand initially to make the progress. Initial progress is very, very important, right? So we got a vacuum tube where we can control the flow of charges, but the problem is that the size is very big, and the next problem is that they consume a huge amount of electricity. So we have moved towards the second thing is we have moved towards a semiconductor. We have moved towards the semiconductor, and in semiconductors, solid state devices basically I'm talking about. So we have moved towards the semiconductors. In that we got diodes, triodes, transistors. There are so many things, and now we are having a microprocessors which is currently also running. Okay, so the theory behind that is these are also known as solid state devices. And these solid state devices, the story starts from the diodes, then triodes, then transistors. There are so many transistors, the microprocessors. Okay, so there are so many things which are still developing. Okay, so this is basically a story behind it. So why this chapter is important? Because in semiconductor, why this chapter is important? Because in semiconductor, we can actually control the flow of charges. Okay, so in a semiconductor, we can control the flow and amount of charges. This is very, very important. And the size of semiconductor is also very small. The power consumption is very less. Size is small. Power consumption is less. Power consumption is less. Size is small. This is very, very important. Got it? That's why semiconductor is very, very important. Now, the question is, what is semiconductor? And why, sir, you have started from a very basic thing that there are matter, there are atoms, there are subatomic particles, and in those subatomic particles, only electrons can move, and right? So basically, I wanted to have a basic clear that we have around 122 elements out there, but in those 122 elements, there are very special elements which have this property in which we can control the flow of electrons, or we can create the electrons in that. And this is what we are going to study in this chapter. This chapter is also not only important for your score, but also important for the particular knowledge about the industry which is going on now. Because if you see any electronic devices, you will find that they have used a huge amount of semiconductor in that. No matter whether you are talking about the electronic devices like a mobile phone or a laptop or a camera or any other thing which you are using, there are semiconductors which were used in that manufacturing. Okay, shall I move forward? Hi, Suraj Kumar Das. Hello. 7P. Okay, that is what I'm doing. Dishita. Okay, now let's move. To understand it better, I need to first start with the band theory. Let me take a very this is basically a prerequisite. You do not require any prerequisite for this chapter. This is the prerequisite which I am taking here. So the prerequisite is that if I am taking a sodium atom, and this is an isolated atom, that means I'm also only having a single sodium atom. Okay, I'm only having a single sodium atom. So this is basically a sodium atom. Okay, now how many of you know about the atomic number of sodium? How many of you know? Do you know what is the atomic number of sodium? I can write a sodium as 11 and 23. So this 11 is the atomic number. So this 11 is the atomic number and this is the mass number. Okay. Now, if you know that how we can do the electronic configuration, I'm not good at electronic configuration, but I know that how to do that. So you have to help me. Okay. So for the electronic configuration, I know that we have to write this thing 1s, 2s, 2p, 3s, 3p, 3d, right? Then it comes to be 4s, 4p, 4d. And then we have to cut it like this, right? This is how electronic configuration is being done. So I can write this 1s2, 2s2, 1s2, 2s2, because in s orbit only 2 electrons can be there. So 1s2, 2s2, 2p6. So how many electrons are done? 6 plus 2, 8, 8 plus 2, 10. Then I'll be having 3s1. Is this thing clear to you? That this is the electronic configuration. And when I'm talking about the electronic configuration, what does electronic configuration shows? According to the Bohr's model, electronic configuration basically tells us about that what is the energy level, right? What is the energy level of that electrons? So if I need to draw the energy levels, how does energy levels works? There is it is similar to the levels what we are having in our stairs, right? If you are living in a society or if you are having your own house, you must be having your stairs. There are stairs, stair 1, stair 2, stair 3, stair 4, ladder like. So I can say that this is the like the first energy orbit. So I could write this as 1s, 2s, p. Okay, so I'm writing here 1s2, s2, p6, 3s1. So these are electrons which we are having here, and in this electron, in this 1s orbit, I am having not need write this thing here. So in 1s orbit, in 1s energy level, I am having 2 electrons. In 2s also, I am having 2 electrons. In 2p energy orbit, I am having 6, 3, 4, 5, and 6. In 3s1, I am having 1 electron. Okay, are you getting my point? I'm drawing this for only a single atom. So for a single atom, which I'm taking here, sodium, the electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. I have done this using this principle. You must have studied this in chemistry. I'm telling you that basically the orbits is equivalent to the energy level, because I am teaching you physics, right? And physicist only sees anything in this world using the 4 phenomena. That is the few physics: force, energy, work, and power. Force, energy, work, and power. Okay, these are only things which is required in the physics. So now this one, these are basically energy levels. These are energy levels of sodium isolated atom. I hope that this point is clear to you. Energy levels of sodium atom. And now, what if I am taking, what if I am taking a sodium gas? What if I am taking a sodium gas? What does sodium gas means? Sodium gas means there are multiple atoms. Earlier I was taking only isolated atom. Isolated atom means single. Single. Only one atom I was taking. And now here I'm taking a sodium gas. That means we are having multiple atoms. And if we are having multiple atoms, then what does it mean? It means that one single atom will be having its own energy, another atom will be having its own energy, and they will merge together. Right? Start thinking in the steps. If you find any chapter difficult, you have to start thinking in steps. And if you start thinking in steps, you will get these chapters very quickly. Right? So what I'm telling you, that if there are so many atoms, let me draw this for you. Like if there are so many sodium atoms, multiple sodium atoms, I'm saying, we are having multiple sodium atoms. Now, due to this, what will be there? The energy level. Earlier, it was for only single atom. Now, this energy level is due to all other atoms. So, what does it mean? It means that earlier I'm having only that due to one atom, I'm having a discrete energy level, or you would say that there were only one value. But when there are so many atoms out there, I'm having a range of values here. Okay, I'm having a range of value here. That what does it mean? It means that there will be some starting level and there will be some ending level. It is similar to the band. Assume that this is your hand. I'm not good at drawing. I'm not good at drawing. But think that this is your hand, 4 fingers and 1 thumb, and you are using a band. 1, 2, 3, right? These are basically band, right? I'm not using any band, but I'm saying that if I'm wearing a watch and if there is some another band out there, I need to wear it. So if there is a separation between my watch and that band, right, there would be some gap, or you would say that there is a range. Like this is the strap of my watch, and it is having a what I could say, it's having a range out there, right? So this is what I am telling you, that if I am having a 1s energy level, there will be a lower energy level and there will be a higher energy level. This is the lower energy level of 1s. I'm having a lower energy level for 1s and there will be a higher energy level for 1s, right? Similarly, the same thing will happen for this 2s. It will also get changed to, okay, I have used, let me draw a label for this. Similarly for this, similarly for, okay. 3, 4, 5, 6, 1 and 2. So here I'll be having a band. So these are basically a band. And these bands are filled. These are known as filled band. Okay. Kamek, am I late? No. Is it clear, my dear, what we are getting here? So in 1s band, this will be a 1s band here, because there are multiple atoms out there which will be having the same energy level, but it is near to that. Okay, that is near to, wait a minute, now it's resolved. Yes. Now, what I was telling you, that here I'm having a 1s band, 2s band, 2p band, 3s band. So these are basically bands, and in those bands I'm having 2 electrons because of n atoms. If I'll say that there are multiple sodium atoms, and I'll consider that there are n atoms out there, so it means that there are 2n. There are 2n electrons, right? Here also there are 2n electrons. Are you getting my point? Are you getting my point? And here in 2p band we are having 6n electron, 3s1. Here only 1n electron. Okay, I hope that this thing is clear to you. Is it clear? Kamek, Dishita, Suraj Kumar Das, Jayvant, is this thing clear? And the last band, is known as valence band. This last band is known as valence band. And the next available band after this is known as conduction band. The next available band is known as conduction band. The next available band is known as conduction band. Okay, I'm erasing this hand. So I hope that this thing is clear to you, that if there were only one atom, we have a discrete energy orbits. This level was having energy level E1, this is having energy level E2, this is having energy level E3, this is having energy level E4. So they are having a discrete energy level. There were only one value. But when there are n atoms, due to that n atoms, the atoms are also being differentiated. One atom is different from the another atom, right? Even if that is of the same material, sodium, but the energy level is different, slightly different. It's like that we know that human beings usually hears from 20 hertz to 20 kilohertz. And if I'm talking about that the frequency at which I'm speaking, right, it may be different from the other person of similar age, similar region, but the voice will be different, right? You must have seen a mimicry person who can take the sound of any artist or actor, right? So how does that how does they can do that? They can do that using the frequencies, right? We can mimic the frequency of any actor. I hope that this thing is clear to you. Is this thing clear? Shruti Yadav? Shruti Yadav from the last class. Okay, also. Now, let me again wind up this band theory, because in this band theory, what you need to understand is that was basically the history, or I would be saying that this is the basic of the band theory. But in reality, I'm not concerned about this filled band, because this is not important for us. For me, the valence band and the next available band, the conduction band, is only important. Okay, so for me, the valence band and the next available band the conduction band. This is valence band. And the gap between the valence band and conduction band is known as energy gap. Okay, this is also known as forbidden zone. You will not find any electron in this zone. Now, below this also, we are having a filled band. But I'm not talking about filled band. My main concern is the valence band and the conduction band. Because due to these bands, the conduction depends, right? Is this thing clear? So here I am having a lower energy level. This is basically a lower energy level of valence band, and this is higher energy level, higher energy level of valence band. And if I'll go here, this is higher energy level, higher energy level of conduction band. This is, let me write it at this point, lower energy level, lower energy level of conduction band. Okay, then the energy gap EG, which I am telling you that this is basically the energy gap. So energy gap is the gap between the higher energy level, the higher energy level of valence band and lower energy level. This is very, very important because I have seen this same statement in your assertion and reasoning questions. So you must know that what is energy gap. So energy gap is basically a gap between higher energy level. This is the higher energy level. So from where I'm going to measure, I'm measuring it from this point. I'm measuring it from this point to this point. So this is the higher energy level of valence band and this is the lower energy level of conduction band. So this is what I'm telling you. So energy gap, and this gap basically decides that whether the material is the conductor, insulator or a semiconductor. So this gap is very, very important. You must remember this gap in your mind. So here I'm telling you that the gap between the higher energy level of valence band and the lower energy level, lower energy level of conduction band. Okay, so this is known as the energy gap. I hope that this thing is clear to you. Is this thing clear? And if somebody tells you that you have to find the EG can be easily find out using energy of higher energy of higher conduction band minus energy of lower valence band. Okay. Now tell me. Rock. Rock with N Naveen. That you do not comes regularly in my classes. Why? Why you're not coming regularly in my classes and you are missing every time? You have to come regularly, right? If you want any help from me, you have to come regularly. isn't it? Now, let's see. I'm adding a periodic table here. This is the periodic table we are having. And in this periodic table, if we see the periodic table, you will find that there are some materials, right, on the left hand side. If I'm drawing a very simple, periodic table like this, so in the left hand side, we are having a metals. In the left hand side, these all are metals, right? These all are metals: lithium, beryllium, sodium. These all are metals. And on the left hand side, you are having non-metals. So there is a complete segregation of metals and non-metals. This side is basically a non-metal side, and the left hand side is metal side. But you are seeing that in between these metals and non-metals, there is a line, a zigzag line out there, which is this line. This boron, silicon, germanium, Sb, Te, At. So this line is very, very important, because these are semiconductors which we have to study in this chapter. These are semiconductors. So can you name them? Can you number them? 1, 2, 3, 4, 5, 6, 7. So only 7 semiconductor elements we are having. Very, very simple, right? But the simplest thing about the semiconductor chapter is that in this chapter, we are only concerned about this group 14, which is silicon and germanium. So only these two elements are our main points. And germanium, we will be preferring germanium because germanium will be having a it works at a lower voltage. There is very less power losses out there in germanium. Silicon is cheap, but the power losses is more. The operating voltage is very high. So if we do not have any concern for the price or for the cost, then we will be using germanium. If we have some concern about the prices or the cost, then we will be preferring the silicon. Okay. But in this lecture or in your syllabus, we have to consider only silicon and germanium. Okay. So this is also a very important point that you have to keep in your mind. Is this thing clear? Now, if somebody asks you that what is conductor, now if somebody asks you that what is the basic difference between a conductor and the insulator, if we are having a matter, then how you can classify that something is a conductor or something is a semiconductor, or if something is an insulator? You know that in your 6th class, 7th class, 8th class, 9th class, 10th class, you have studied a very basic definition that the material which do not provide any resistance to the flow of charges or the flow of current, we say that this is a conductor, right? But we are not going to use that definition here. Here, what is main important point is that whenever there are two conditions, whenever we are having a conduction band and a valence band, see, here I'm considering this is a valence band. Here we are having conduction band, valence band. Conduction band and valence band are overlapped here. Here the gap between the conduction band, here the gap between the conduction band and the valence band is less than 1 electron volt. So the first point is that when either, or I would be, it will be better if I'll write this points. So either conduction band, and valence band overlap either conduction band and valence band overlap, or second one is the gap Eg is less than 1 electron volt. Okay, so whenever we are having these conditions that either conduction band and valence band are overlapping, or you could say that the gap between the higher energy level of valence band and the lower energy level of the conduction band is less than 1 electron volt, then we will be saying that this material is a conductor. Similarly, if we are talking about a semiconductor, right? If we are talking about a semiconductor, then what is the value here? This is 0.1, 0.1, 0.1. Now, if I'm talking about here, semiconductor, then for semiconductor, we considered semiconductor when Eg is less than 3 electron volt. And for insulator, this Eg is basically greater than 3 electron volt. Okay, now here I could write that Eg is greater than 3 electron volt. This is my first point which you have to remember. Okay, the first point is about the uh, energy band, energy level which we are having. And the next point is about the conductivity. Here, if I'll talk about the conductivity, conductivity is the reciprocal of the resistivity we are having. So the conductivity is 10 to the power of 2 to 10 to the power of 8. And similarly, if somebody talks about a resistivity, if somebody talks you about the resistivity, that will be equals to 10 to the power of minus 2, 10 to the power of minus 8. These are very, very important points. Okay, Naveen, call me, sir. You will give me your number, I will call you. You will give me your number, just drop your number, I will call you. Okay. Or you can do one thing, you can call on Rankplus number 9116 300 and you can say that you want to talk with Manoj sir. They will connect you with me. Okay. That is also options for everyone. If you want to directly call me, you can do one thing. You can call on a Rankplus number and you can tell there that you want to connect with me. So call on 9116 300 and tell them that you want to talk with me. Okay. They will divert the call to me. Now, the second thing is here. Now here, if I need to find out the conductivity, so what is the value here? Conductivity, I'm talking about a conductivity here. Okay, 10 to the power of 5 to 10 to the power of minus 6. And similarly, if I need to find out the resistivity, that will be minus 5 to 10 to the power of plus 6. So this is also very, very important. Okay, Naveen, I hope that that point is clear to you. Now, here 10 to the power of minus 11 to 10 to the power of minus 19. Similarly, if you have to find out the resistivity, it will be 10 to the power of 11 to 10 to the power of 19. Now, why these values are important? Because I have seen that in multiple questions, you are provided with these values, but in sometimes it could happen that these values will not be provided to you. So you must remember at least a particular range where these numbers are lying. That what is the conductivity range, what is the resistivity range for the conductor, semiconductor. At least I want that you must be remembering for either a conductor, insulator, or semiconductor. One thing you must remember. Okay, and you know that what is the ideal thing? Ideal thing is that you can remember very easily that from 11 to 19, 11 to 19, 11 to 19 is very easy number, right? 2 to 8. So remember that from 2 years to 8 years you will be like enjoying your life. From 11 year to 19 year you have to do a lot of hard work, right? Because if you do a very good hard work in these years, your other like you will get the success which you want in your life, because ultimately if you will get the good college and everything is sorted out, right? Shall we move forward? Like, I'm moving forward. Let me explain you something here. Okay, now we know that we know that that there are 7 semiconductor elements. Okay, and in these semiconductor elements there are some properties. There are some properties which you have to keep in your mind. Properties of semiconductor, that at 0 Kelvin they behave like an insulator. At 0 Kelvin they behave like an insulator. Okay, now if also other than that, the temperature coefficient, temperature coefficient alpha is negative. So if you increase the temperature, your resistance decreases. As you know that as we know that R is equals to R naught 1 plus alpha delta T, and if this alpha is negative, and if this alpha is negative, then if you increase the temperature, your resistance will be decreased. This is a very important point, because you must know that for a conductors the alpha is positive. If you are increasing the temperature, the resistance will be decreased. Okay, I hope that this thing is clear to you. Sir or ma'am, can we make a video on preparation strategy on VIT? I think that there is already, the video is already there by Nabamita ma'am, isn't it? He had taken a session. Is it there or not? Tell me. I'll check. I'll check. Check. Is it there or not? Please let me know. I think that it's. Do we have? Tell me, any doubt here? Wait. Okay, now I think that this thing is clear to you. Now let's move. Okay, now let's have some prerequisite, or I would be saying a knowledge booster. Knowledge booster dose. Let me check your chemistry, that how good you are in inorganic chemistry. I'm taking a group 13, group 14, a group 15. For group 14, you can write NPAS. For group 15, you can write NPAS. For group 14, you write. Now, you know that there are some tricks, and you have to remember these groups. You have to remember these groups. There are tricks. There are multiple tricks to remember. Right here, it's ball gain tail. Okay, now I can show you from this also. This boron, aluminium, gallium, indium, thallium, carbon, silicon, germanium, tin, lead, nitrogen, phosphorus, arsenic, antimony, bismuth. So these are the groups which is required. These are the groups which is required, and you must learn these groups 13, 14, and 15. Okay, this is what I'm writing here. You have to remember this. Balgain tail, the trick is Balgain tail, college sister getting some problem, Nana Patekar, Aishwarya, sab bindas. Okay, these are the tricks. There could be multiple tricks. Have you please tell me the tricks which you have used to remember this thing? Do you know any trick to remember? Your chats are not coming. Tell me. Chats are not. So can ma'am SP rock with Naveen? Is this thing clear? Now the important point is for this group 13, you have to remember this group, right? For you have to remember this group. College sister getting some problem. Now The important point is, if anyone asks you that what is the valency here, so here the valency is 3. And if somebody asks you that what is the valency here, so valency is 5. And if somebody asks you that what is the valency here, so valency is 5. So this is also known as pentavalent. This is also known as pentavalent. This is also known as trivalent due to its valency. So this 15th group is also known as pentavalent, and this 13th group is also known as pentavalent. I hope that this thing is clear to you, right? Is this thing clear? Now let's move towards the next part. The next part is the types of semiconductor we are having. So in types of semiconductor, we are having, first part is intrinsic semiconductor, intrinsic, and the other one is the extrinsic semiconductor. Intrinsic is also known as I-type semiconductor. This is also known as I-type semiconductor, or a pure semiconductor, pure or elemental semiconductor. I'm taking here silicon, 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 silicon. Okay. Now you know that silicon is from group 14, and group 14 basically forms a covalent bond. And I'm showing you the covalent bond. This is a covalent bond. Here we are having a covalent bond, covalent bond, covalent bond, covalent bond. It's like a kabaddi, kabaddi, kabaddi. So there is also a covalent bond, covalent bond, covalent bond, covalent bond. Here also a covalent bond, here also a covalent bond. Now at 0 Kelvin, all the electrons are basically used in forming the bonds, right? So at 0 Kelvin, we do not have, at 0 Kelvin, there is 0 free electrons. So if we do not have the free electrons, I could say that these are basically acting like an insulator. Because at 0 Kelvin, we do not have any free electrons, because all the electrons being used in forming the bonds, which is known as the covalent bond, and there is no free electrons available for the conduction. Similarly, we can say that if we do not have the free electrons, then I could say that this is acting like an insulator, right? But what will happen at higher temperature? The bonds will break. At higher temperature, I could say that the bonds will get break, and once the bonds gets break, there will be some free electrons available for the conduction. Then only conduction can happen. At higher temperature, bonds break. At higher temperature, bonds break, and when the bonds get breaked, at higher temperature, when the bonds break, we have free electrons. And these free electrons helps in these free electrons helps in conduction. So that is why we always say that in case of intrinsic semiconductor, we are depending upon the temperature for the conduction. So we cannot depend upon a like a physical condition of temperature for the conduction to happen. So that's why we have to explore some other options, right? So the other option is that we have to create a permanent bonds, or we can say that we have to explore the permanent options where we are having the free charges always being available. So for that we have to create the extrinsic semiconductor. And if I'm talking about the extrinsic semiconductor, here we used to dope, we used to add some impurities, add some impurities in the intrinsic semiconductor. And by adding the impurities, we generally increasing the number of free electrons being available. So extrinsic semiconductor is divided into two parts, the p type and the n type. So I'm having types of semiconductor here, p type and the n type. Okay, p type and n type. In p type we use trivalent impurities, or acceptor impurities. These are known as dopants. Dopants are basically from group. Dopants are from group 13. If I'm considering the base, I'm considering the base or the intrinsic semiconductor to be from group 14. Okay, then I'm saying that I'll be using the dopants from group 13. Similarly, here in n-type semiconductor, we will be using a pentavalent impurities. And in these pentavalent impurities, I could say that we will be having a donor impurities. This is also known as donor impurities. And the dopants are group 15. And the dopants are group 15. Okay, remember one thing, that both of them are neutral. Okay, some peoples are confused that this p type is positive and n type is negative. It's not like that. These are totally neutral. Both of them are neutral. This is also neutral, this is also neutral, both are neutral. Okay, both are neutral. I hope that this thing is clear to you. So ma'am has done a video about the exam and college only, sir. Ma'am did not say anything about the preparation strategy. Can you make the video on the preparations? I will make that. At what time the number will be available? Number will be available from in the office hours, like from 9 a.m. to 11, 9 to 6, I think that it's available, or 9 to 7. You need to check. But you can call on that number, 9116 300 300. So basically, SP, which type of help you want for the VIT? VIT is a very simple exam. You just need to cover your NCRT for class 11th and 12th, and I'm also having a book for VIT previous year. VIT previous year is available in the market. You can purchase it from Amazon or the Flipkart and get it done. You have to solve it. This is the only options. Yes. Shall I explain you the intrinsic semiconductor now? Extrinsic semiconductor. Shall we move towards the extrinsic semiconductor? Shall I explain you? Yes. Now, let's move towards the extrinsic semiconductor. If I'm talking about extrinsic semiconductor, this is what I have discussed. That there are two types of extrinsic semiconductor. The first one is a p-type semiconductor, and the another type is n-type semiconductor. In p-type, we are combining a trivalent. We are combining a trivalent or acceptor impurities plus a group 14 we are taking, plus a group 14 or a intrinsic semiconductor we are taking, and when we combine it we are getting a p-type semiconductor. In this p-type semiconductor, the majority carriers is holes and the minority carriers are electrons. Similarly, if I need to write the similar thing about n-type, if I need to write the similar thing about n-type, then we are using a pentavalent impurities. We are having donor here. This is the n-type. So if we are having a pentavalent impurities, which is also known as the donor impurities, because it will be providing the electrons to the intrinsic semiconductor, we will be making a n-type semiconductor. These n-type semiconductor will be neutral. Here the majority carriers will be electrons, but the minority carriers will be holes, right? If you want to see it in a bond formation, I'll also make that arrangement for you. Let me show you. If I'm having an intrinsic semiconductor like this, okay, if I'm having an intrinsic semiconductor like this at this position, okay, now I'm adding what here? I'm adding a trivalent impurities. So can consider a gallium here. If I'll add a gallium, you need to break this. Okay, this thing is broken. We're having GA here. This gallium is having a trivalent. This is basically a trivalent atom. So this will provide me a 3 electrons. So one bond here, one bond here, one bond here. But here I do not have the electron out there. there will be a hole. This bond will not be formed. So we will be having a hole here and a electron. We are having a hole here and the electrons. So due to addition of one gallium atom, due to addition of one dopant, you are basically creating a one hole and one electron. Is it clear? So this is what is happening here. And similarly here, if I'm taking arsenic here, similar approach you can. You can form, because we know that arsenic is a pentavalent, so you can make five electrons will be there. 4 electrons being used for making the bond, a covalent bond, and the another one will be available as a free electron. Another one will be available as a free electron, and due to that we are having the extra electrons present in case of an atom. That's why we are saying that the majority carriers are electrons but the minority carriers are holes. But why I'm saying that these all are neutral, because the dopants which we are adding, this gallium is neutral, this is neutral, so we know that the charges cannot be created nor be destroyed. So ultimately for the complete solid we are having the neutral body. Is it clear, my dear? It why I'm saying that the complete atom is neutral. Okay, now this is very important. And for the numerical part, this is the concept behind this. For the numerical part, we have, for numerical we have a very simple formula that Ni square is equals to Ne into Nh. A very simple formula which we have to learn for solving the numerical. Ni square is equals to Ne into Nh. Ni is the intrinsic number of carriers in the intrinsic semiconductor. Ne is the number of electrons we are having, and the Nh is basically the number of holes we are having. Is it clear, my dear? And by adding one dopant, basically what you are creating is you are creating the one electron, or you are creating a one hole in this type, p type. And here if you are adding one dopant, basically you are creating one electron. This is what is required. Shall we move forward? Now once this semiconductor is done, the another thing is diodes. So how does diode forms? Diode is basically a combination of p and n type. Diode is basically a combination of p and n type. So you can write this as p and n type. Symbolically, we have generally provided the metal connections with it. The symbol for this is the symbol we are having. The symbol for this is Pn. Okay, now this is the positive side, this is the n side. You must remember that there is biasing, or let me, it's not required that I'll be going to explain you the complete formation of PN junction. You can skip that. I would be suggesting you that there is one homework for you. Read the NCRT, read NCRT for formation of PN junction. Get the basics right. This is very, very important. But here I'm going to discuss only the important point. The important point is about a biasing. Biasing is connecting a voltage. Biasing is that we are connecting a voltage. And when we are connecting a voltage, there are two types. Forward biasing and the reverse biasing. Forward biasing and the reverse biasing. In case of forward biasing, this P side will be connected with the positive side of the battery. This P side will be connected to the positive side of the battery, and the N side will be connected to the N side of the battery. And here in the reverse bias, what is the main fact here? That we have connected the negative side with the P side of the diode. Okay. Now, the basic difference what we are getting here is that there is particularly a voltage out there. There is a breaking voltage because of this very small width we are having here. This is that due to this width, I'll explain you. See, when one side is P side and the another side is N side, here in P type semiconductor we are having a lot of holes out there because majority is holes, and here the majority is electrons. Due to the difference in majority, due to the difference in the majority carriers, the holes will move from here to here. The holes will move from north side, the holes from P side will move towards this side, and electrons from this side will move from N side to P side. Okay, the first process which is happening here is diffusion. There are two processes which are happening. The first process is diffusion. Diffusion is due to concentration difference. Diffusion is due to concentration difference. So when there is concentration difference between the P side and N side, we are seeing that the holes are moving from P side to N side and the electrons are moving from N side to P side. And plus, once this electrons will move to this side, we are getting a potential barrier, because here the electrons will be immovable, and we are getting holes at this side which are also immovable. So there we are getting a junction being created which creates a further barrier potential, and that potential needs to be crossed if we want to get any conduction. And if this barrier, I'm drawing that this is the voltage or the barrier we are having, which we need to break, or you can write this that if this is unbiased, then for the forward bias, This is forward bias. This is for the reverse bias. Okay. So basically for the reverse bias, the potential barriers increases. For the forward bias, the potential barrier decreases. Potential barrier, I'm talking about VB. This potential barrier decreases for the forward bias. For the reverse bias, it is basically increased, and for the reverse bias, it basically decreased. Is it clear, my dear? Biasing is basically connecting the voltage. If you're telling that we are connecting a P side with the positive side, then it will be forward bias, and if we are connecting the negative side, then it will be a reverse bias. And due to this, we'll be having IV characteristics. For the reverse, this is the breakdown voltage. The breakdown voltage, knee voltage. Draw it now. If I'm considering an ideal diode, case of forward biased, behave like an short circuit. Example, 2 ohm, one diode is there. This is an ideal diode we are having. And here I'm having a 10-volt supply, ideal diode. So this is basically a forward bias connection. I can do one thing. I can substitute this to this. And here I could join like this. And if somebody asks me that what is the current here, so current will be equals to the voltage 10 divided by 2, and you will be getting a 5 ampere. So this is the current which you will be getting. This is the forward bias. And if somebody asks you, tell the reverse bias, what will happen in case of reverse bias? So in case of reverse bias, I'm having that this diode will behave like an open circuit. This diode will behave like an open circuit for the reverse biased. Oh, no current will flow here because this is reverse bias, and in reverse bias I'll be considering that this circuit is open. Okay, so these are two conditions which you need to remember, that what will happen in case of forward bias and what will happen in case of reverse bias. This is very, very important. Now, I think that this thing is clear to you. In case of practical diode, because sometimes we must get the practical diode condition as well. In case of practical diode, we will be replacing the diode with the voltage we are having. Okay, like here, if there is a potential difference, because there will be a drop out there, so I'll be considering, let me show you that what will happen here with the same example. I'm considering that here the breakdown voltage is zero point 0.7 volt. I'm considering the breakdown voltage is 0.7 volt. So to solve this question, what you are going to do is, and the resistance also being provided, that the resistance will be, resistance is 0.02 ohm. Can do one thing, can replace this 10 volt, a reverse voltage 0.7 volt, and a small resistance of, and this is the circuit which you need to draw. And if somebody asks you that what is the current here, you can apply the Kirchhoff's law. And by applying the Kirchhoff's law, you can easily get that it is 10 minus of 0.7 divided by the resistance is 2.02, the total resistance, and the answer will be 9.3 divided by 2.02. So that is the value of the current we are having. Okay, you can solve it. Nothing. No, I'm teaching to you. So it's 9.3 divided by 2.02. Why you think that I'm teaching to board? So the answer will be 4.603. The answer is 4.603 ampere. Okay. See, when the numbers, when I'm not seeing any chat, what can I do? I can do one thing, that I should not see the chat, and I should create the video in such a manner that even if the student watches it after the live class, he will not be feeling that he is missing out something, right? So the energy level must be maintained. That is the most important factor which I have to keep in mind when I'm taking the live session. Okay, I hope that this thing is clear to you. Is this thing clear? Now, if this thing is clear, we can move forward regarding the logic gates. Logic gates, this is very important topic. And if you ask me, it's a which is the topic, if if you have a very limited time and you have a time to just go for one topic only, I will be suggesting you that this is the topic which you must do, because every year you will be getting, in every shift there is one question from one topic which is logic gate. So logic gate is must to do topic. Logic gate. So what does logic gate tells us? There are two types of gates. One is basic gate. Basic gates are AND gate. The symbol for AND gate is this. We will provide two inputs and there will be one output. It might also be there that you will be having multiple inputs out there, but your output will be same. And the output here is basically a product of A and B. The output is the product of A and B. Second thing is you are having an OR gate. In OR gate, that is A plus B. And the third thing is NOT gate. So the NOT gate is this one. So here one is input and one is output. So your C is equals to A bar. These are three basic logic gates which you have to keep in your mind, and this is very, very important. There are three basic gates: AND gate, OR gate, and NOT gate. And other than that, we are also having universal gate in our syllabus. Universal gate, why we say them a universal gate? Because using these gates, you can create any other gates. Using this universal gate, you can create any other gates. So universal gates, we are having XOR and XNOR. That is a special gates. NAND and NOR in your syllabus. NAND gate is actually a combination of AND and NOT. Here it is A, here it is B, and the C part is AB bar. Could write it as A bar, B bar. Also, we are having OR gate. OR gate. This is A, this is B. So the C will be equals to A plus B bar, A bar dot B bar. But before I will be going to discuss the actual logic behind these gates and how we are going to solve, we must be knowing some very basic mathematics, which is known as Boolean algebra. Boolean algebra is usually required when we are dealing with binary numbers. And in this, you must be knowing that how we are going to add the binary numbers and how we are going to add, subtract, multiplication, division of the binary numbers, right? So, yes, nothing. Hi, Jay Chintan. Hello. So, Boolean algebra you must know. First one is the addition. Addition of Boolean algebra. First, 1 plus 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1 is 1 here. 1 plus 1 is 1 here. That you must remember, because we know that in Boolean algebra, we have only two numbers, 1 and 0. 1 you can say that it's true. 0 you can say that it's false. You can say this as high Okay. So it's 0 plus 0, 0, and you can write this as subtraction. Or subtraction is not required. What is required? I'll things. Let's see about the multiplication. 0 into 0 is 0. 0 into 1 is 0. 1 into 1 is 1. Okay. Also, let's learn something about truth table. Let's learn about something truth table. So, as we know that we will be using only two numbers, 2 to the power 0 is known as 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. Okay, this is how we are going to proceed for the truth table. I'll start it from 2 to the power of 0, which is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. And similarly, you can exceed it, right? But you won't be getting like a more number from this. So if I am I'm keeping everything as 0 and I'm keeping a 1 here, what does it mean? It means that I'm writing 1 here. Means that I'm writing 1 here. Okay. Means that I'm writing 1 here. I'm writing a number. Number 1 here. If you want to write 2, please use your logic here. This is logic gate. So you must be using your logic. So if I'm writing 2 here, 2 means what? I want 2 only. So I'll be using this. I won't be using this. I won't be using this. I won't be using this. Take a very classical example, which I used to take when I am teaching this topic. I'm having a rupees 50 note with me. I'm having a rupees 20 note with me in my purse, in my wallet. And I'm also having a rupees 10, rupees 100 in my wallet. Okay, I'm having these many notes in my wallet. The numbers are indefinite. I do not I do not count that how many notes I'm having. But if I'm getting a bill of 250 rupees, if I'm getting a bill of 250 rupees, then what must be an ideal way to give it? The ideal way will be I'll be using two notes of 100 and one note of 250, right? I'll be using two notes of 100 rupee and one note of 50 rupees to pay this. Is it clear, my dear? Similarly, I'm writing this that if I'm writing a 1 here, it means that I'm taking 1. It means that I'm taking 1. If I'm writing 1 here, it means that I'm taking 2. That means I'm only having 1, 2, 4, 8, and after that 16. These are the numbers which is available. And using these numbers, I have to create numbers. Using only 1, 2, 4, 8, I have to create ultimate numbers whichever I want. So to create 3, how can I create 3? Tell me, how can I create 3? Uh, 3 can be created using 2 and 1. So I'll be using 2 and 1. Other numbers I won't be using. Okay, other numbers I won't be using. And after that 4, if I want 4, 1, 0, 0. Similarly for this, if I want 5, you tell me that how you can make the 5. 5 you can make using 4 and 1, right? So you can write 1 here, 1 here. Uh, Everything is 0. And if somebody asks you that how you are going to make 6, so for 6 you will be using this and this. Everything will be 0. I hope that this thing is clear to you. Now let's make the 7 as well. Let's make the 7 as well. Please participate in this. Please do let me know in the chat how you are going to get 7 here. How you are going to get the 7 here. Please let me know. If I want to write the 7, how you are going to get 7 here. For 7, you could use 4, 2 and 1. So it will be 1, 1, 1. You will be getting 7. And for getting 8, you can write 8, 1, 0, 0, 0. And you know that I'm a kind of a teacher who looks for the pattern. I'm a kind of a teacher who looks for the pattern. And if you are observing this thing, you are getting that here it's 1, then it's 0, then again it's 1. See, it's 0, it's 0, it's 0, it's 0. Alternatively, they are coming 1, 0, 1, 0, 1, 0. Now, if you go here, you are getting 0, 1, 1, 0, 0, 1, 1, then again 0, 0 will come. Here you are seeing that 4 times 0, 4 times 0 it will come, then 4 times 1 will come, then again 4 times 0 will come. And it here you will be seeing that 8 times 3, 4, 5, 6, 7, because I haven't tried the 0 here. 4 times, 8 times your 0 will come, and 8 times your 1 will come. So this is basically a truth table. And using this, did you complete Zener diode? No, I haven't. Zener diode is basically used for the voltage regulation. Hawkeye. Your name, like Hawkeye is one of my favorite Avenger, right? Hawkeye is one of my favorite Avenger. So I hope that this thing is clear. Now, these are our basic logic gates. We must be knowing how to form the truth table. How to form the truth table. This is logic gate. This is basic gate. And if I'll consider the first gate, which is the AND gate, so for AND gate, you are having 2 inputs giving you 1 output, and the output condition is that they must be a product of the inputs which you are providing. So it will be 0, 0, 1, 0. I told you 0, 1, 0, 1, 0, 0, 1, 1. So this is the way to write it. How I am writing this? I told you that this number will be equal to 2 to the power of 0, which is 1. And this is 2 to the power of 1, which is 2. Okay. And here you could write 1, 3, and 4. Okay. So see, if I'm writing 1, 1 is not that 1. If I'm writing the first, what I'm getting, it's 0, 0. It's 0, 1 is 1 actually, and 1, 0 is actually 2, and this is 1 and 1 is 3. Okay. So if I have to multiply, or you might get confused from this, I'm removing this thing. So if you have to multiply, you'll be getting 0 here, 0 here, 0 here, and 1 here. So when both the inputs are high, you will get the result as high. When both the inputs are high, you will get the result high, right? Let me draw one. Let me draw one something for you. A, this is B. There is a bulb. This is basically a simple representation of what I wanted to show you. If this A key is on, then also the bulb will not glow. If B is on but A is off, then also the bulb will not glow. The bulb will only glow when both the keys are on, like A and B. When both the keys are on, then only the bulb will glow. So this is an example of AND gate. Similarly, we are having the OR gate. Similarly, we are having an OR gate. I can write it here. OR gate. For OR gate, A, B, C is equals to A plus B. So my truth table will look like this. C is equals to A plus B. This is 0, 1, 0, 1. And here I'm having 0, 0, 1, 1. Okay. So it's 0, 0 will be, I have to add 0, 0 will be equals to 0. 0 plus 1 will be equals to 1. 1 plus 0 equals to 1. And 1 plus 1 will be equals to 1. So if any input is high, I'll be getting a high. If any input is high, I'll be getting a high. So this is OR gate. And for the AND gate is very easy. This NOT gate is very easy. Because for NOT gate, we are only having one input. For NOT gate, we are having only one input. And using this input, if this is A, here the output is A bar. If I'm writing A and my C is equals to A bar, if I'm having 1, I'll be getting 0. If I'm having 0, I'll be getting 1. So simple. And now I think that we are ready to solve the question. Hokai, nice beard. Thank you. Vinay Singh Bagel. Where are you from? Bagel is a surname from UP, I think. Uttar Pradesh. Are you from Uttar Pradesh, Vinay? Now it's time. These are the topics which we have to cover. Semiconductor IV characteristics. Okay, diode as a rectifier. I'll do that thing also. Diode as a rectifier. Diode as a rectifier. Or let us understand the rectifier. Rectifier is basically changing the alternating current into DC. So it is basically a device to change AC into DC. It's very simple. If I'm having an AC connection, I'll use a transformer for stepping it down, and I'll keep one diode here. This is my diode. If the input is like this, my input voltage and the time, I'll be getting an output. So my output will be, this is a half wave rectifier. For one cycle it will work, for another cycle it will start work, but it won't work between. So this is basically a half wave rectifier. For half wave it's working, for half wave it do not. This is half wave rectifier. The frequency of this rectifier is F. If the input frequency is F, the output frequency will be also F. Okay, the output frequency will also be F. Now for the full wave rectifier, there are multiple methods of making the full wave rectifier. The easiest one is to take a transformer here. I'm using a step down transformer. I'm using one diode here, that is D1, another diode here, that is D2, but I'm using a center tapping transformer and I'm keeping a load here. And due to this, what will happen? If the first cycle, here I'm getting positive, I'll be getting negative here, here positive and negative. So at one time, only one electron will work. So for one cycle, I'm considering this as the input. So if this is the input, my output will be like this. This is from diode D1, and for the negative cycle, this will be working. D2 will be working. For another positive cycle, D1 will be working. For negative cycle, this D2 will be working. So this is how we will get. But the frequency here is F out. If somebody asks me that what is the frequency of the output, the F output here is 2F. It's twice the frequency of the input frequency what we are having. So these are half wave and full wave rectifier. Rectifier is basically used to change or convert the AC into DC. This is very important topic. You will get the questions directly from these topics. Similarly, we could have a bridge-like structure as well. You just need to remember that if the diode is forward bias, you can easily take that condition. Okay, now let's solve the questions from, now it's time to solve the previous year questions. This question is from 24th of January shift 1. I'll give you a timer. I'll give you a timer as well, because these are assertion reasoning questions. You need to understand that what is the real answer. You must be using your brain. Don't be fully depending upon me. You have to use your brain here. I'm giving you only 30 seconds. I think 30 seconds is, oh, it's going in minutes. I think that 30 seconds is more than enough to solve these types of questions. Now solve it. So here you are having an assertion. Here you are having an assertion. So assertion is photodiodes are preferably operated in reverse bias condition for light intensity measurement. So I'll be like covering the spatial diodes using these things. Okay, Vinay Singh Begal, please do let me know that what is the answer. I'm not getting any answers from anyone. Why? Is this very difficult or you require some more time? Please do let me know why you are not giving the answers here. Let me share this session again with my students, and do share these sessions with your friends, because currently we are going to do the previous year questions, and these questions are very very important, right? These questions are very very important if you really want to crack the JEE exams. The theory is one part. The important part is that you must be able to solve the previous year questions when you are attempting it, and this is the real check. If you are not able to solve the previous year question, that means that the theory which you have done is not sufficient. Attempt this. Want another 30 seconds? I'm not getting any answers. It's so much difficult. Why I'm not getting the answers? Oh, please do let me know. Time up, my students. Time up. Time go on. Alright, tell me what is the answer. See, photodiodes are preferably operated in reverse bias condition for light intensity measurement. The current in the forward is more than the current in the reverse bias for PN junction. For a PN junction, it's basically telling us that for a PN junction, right? This assertion is true, this reason is true, but this is not the correct explanation. That basically it's not explaining this thing. So I could easily mark that this both A and R are true, but R is not the correct options. Okay, now next. The next question, 30 seconds I am giving you. The logic gate equivalent to the given circuit diagram. Here I'm having a plus 5 volt, and here if there is a ground here, I'm having a 0 volt, and there is a resistance R. There is a bulb here, there is a bulb here. Now you tell me that when will this bulb glow? And we have already done this question. You see that the moment we have, like the moment we close this both inputs A and B, the moment we close both these inputs A and B, they will be short circuited, right? They will be short circuited. This bulb will not glow, because the easiest path what this bulb will get will be from this side, isn't it? This bulb will also having some resistance, right? Tell me. So this will not be an AND gate. This will not be an OR gate. Please tell me that what it could be. This is NAND gate. AND gate it is. Now next, move towards the next question. Solve this. In this question, assertion and reasoning is provided to you. According to the assertion, photodiodes are used in forward bias usually for measuring the light intensity for a PN junction diode at applied. So this question is from 25th January shift 1, that photodiodes are used in the forward bias, right? In the previous questions, what we had done in this question, you have seen that photodiodes are preferably operated in reverse mode, right? So you know that when you are solving the previous year questions, you have to be well aware that on which topic the questions are coming. So the questions are coming on photodiodes. That what is the basic biasing in the photodiodes? You know that the basic biasing in photodiodes is the reverse biasing. So I could say that the first option is wrong, right? The first assertion is wrong. And the moment I see that assertion is wrong, I could easily mark that third is my answer. I am not going to read the reason in my exam, in the real exam, if I'll be sitting, but here I'm teaching you. So if I'm teaching you, I would be reading this, that for PN junction at applied voltage V, current in the forward bias is more than the current in the reverse bias. Okay, that is very good. I hope that you are learning from the previous year questions. You know what? In the last few months, which is left, the most perfect strategy for you is to solve at least 5 years PYQs and read the pattern of the questions, right? You do not need to be worried about that what they have asked in the question. You must be worried about that on what topic they have asked, right? The topic for me is the photodiode. So I must be knowing that what is the photodiode, what is the basic type of biasing in the photodiode. As you are seeing that they are only asking you that what is the biasing here. So photodiode usually works in the reverse bias. So this is the logic which you must know. And if you know that thing, you can easily mark this question also. So this question is also from the January shift. Another question we are having. This is the statement 1. When a silicon sample is doped with boron, you know that silicon is from group 14 and boron is from group 13, right? This is from group 13. This boron is from group 13 and group 13 is trivalent. So you are going to get which type of semiconductor? P type. It becomes P type, and when doped with arsenic, arsenic is from what? Group 15. It's pentavalent. You're going to get N type semiconductor, such that P type has excess holes and N type has excess electron. The complete statement 1 is correct. Are you getting? Very basic, isn't it? So first statement is correct. In the second statement, when such P type and N type semiconductors are fused to make a junction, a current will automatically flow, which can be detected with an externally connected ammeter. False statement. This is false statement. So my answer will be that statement 1 is correct, but statement 2 is incorrect. Easily I can mark this question if we know the basics of the semiconductor. Is it clear, my dear? Let's move towards the next question. This is the next question. This was asked on 22nd of January, shift 1. In this question, which of the following statement is not correct? So they are asking you that which of the following statement is not correct. And in the case of light emitting diode, so basically they are asking us LED. You have to tell that in case of LED, which of the conditions is true. So it is heavily doped PN junction. It emits light only when it is reverse bias. The energy, you are seeing that photodiodes are coming again and again, and we know that the energy of the light emitted is equal to d slightly less than the energy gap of the semiconductor. You tell me that which could be the answer here. Tell me. Tell me. Please remember one thing, that you have to mark the thing which is not correct. Okay, remember one thing. You have to mark which is not correct. So most of these terms are correct. You have to mark which is not correct. Incorrect you have to find out. It is heavily doped PN junction. It emits light only when it is forward bias. It emits light only when it is reverse bias. See, when I'm reading the options, I'm getting that these two statements are counter. Like this statement is reverse to this. So I can see that, out of these statement only I'm getting the answer, right? So I know from my knowledge that it emits light only in forward bias. This is correct. So the only incorrect statement here is C, and this is the correct option which you have to mark. I hope that you are getting. And if you really wanted to know about that what is LED, these are the points what you have to keep in your mind, right? These are the points what you have to keep in your mind. Now let's move. This is a question from a logic gate, and it will take around 1 minute of you to solve it. Question is from 29th January shift 2. For the given logic gate combination, the correct truth table will be. And you know that how to solve it. The easiest method to solve it is using the Boolean algebra. And the other thing is to provide a pseudo inputs as per the logic gate or the truth table you are having. So I'll be using, if there is A, I'll be getting A bar here, and B is coming directly here. This is the AND gate, A bar B. A is coming directly here, bar, having A B bar, and here you are getting A bar plus A B bar. Okay, this is what you are getting. Tell me now. Just consider this thing. If you are having A as 0, I'll be having 1 here. 0 is 0 and 0. So my answer will be 0. So these two options can't be my answer, right? Because for 0 and 0, it's coming out to be 0. Now see, I'll not be checking for these two options because these options are similar. I'll only be checking for 1 and 1. So if I'll keep this as 1, it will become 0, right? So I'll be getting 0. Great. Very good option. First, solve it using the simpler method, and then use the options what you are having and use the truth table. Put the values from the truth table to get the answer. Now again, this question is from 30th January shift 1. Here you are being provided by a very simple circuit, and you have to find out that if this is the input what you are getting, then what could be the output. The output waveform of the given logical circuit for the following inputs. So these are the inputs which you are providing to these logic gates. Then what could be your output? So I know that this gate is acting like an AND gate, not gate basically. So that will be A bar, and here I am having a B bar, and this is the NAND gate. This is the NAND gate we are having. So NAND gate is basically A bar dot B bar bar. So I'm getting A plus B. So this is equivalent to, this whole circuit is actually equivalent to a OR gate. Are you getting my point? This whole circuit is actually a OR gate, very simple OR gate. Just now tell me that what could be the answer. Tell me what could be the answer. 1. This is 0. This is 1. This is 1, 1. 0, 1. 0, 0. 0, 1. So 0 plus 1, 1. 1 plus 1, 1. 1 and 0. T4, between T4 and T5, it's 0. So my answer will be 4th. Okay, you have to keep your eye on the options to get the correct answer. Now, again, we are having a question from the logic gate. We have to find out the output Y for the input A and B of the circuit given. Okay, fine. So A and B. So if this is A, here this is A, I'll be having A, B, B. At this point, I'm having A, B. This is AND gate, AB bar. Okay, and this AB bar being provided to both the inputs we are having. So again, you are having the AND gate here. Dot bar bar. And then you have to find out the output. I think that it's getting complicated if we are solving in this way. So it's better to check the options. If you are providing a 0 here, if I'm providing a 0 here and 0 here, I'll be getting 0 and 0, 1 here. So this is 0, right? Or let's solve this. What getting? I'm taking this as CD bar bar plus D bar. So it's AB bar plus B AB bar. AB bar you can take common, and it's A plus B. Okay. Now just multiply 0 and 0 means 0. 1 I am getting. Okay. The answer will be 0. 0, 0, 0. So this won't be my answer. This won't be my answer. 0 and 0, I am knowing that I am getting the 0. If I'll substitute the 1 and 1, 1 and 1, it will be 1, but it will ultimately become 0, right? Here, this option is not correct, means I'm not able to see the option. But here I know that this won't be my answer. Why? Because here 1 and 1, it's 1. If this option I'm not able to see, but I think that you will be able to see. I'm not able to write with fine pine. Yes, it's 1 and 1, 0. Okay. Now, if this, yes, this is the correct option. You just have to check the inputs, what we are getting, right? Using the inputs, you could easily get the answers. Next, 31st January shift 1. 31st January shift 1. 31st January shift 1. Now tell me, the effect of increase in temperature on the number of electrons in conduction band and the resistance of the semiconductor. Earlier we were discussing these two bands, right? The conduction band and the valence band. So they are asking that if you are increasing the temperature, by increasing the temperature, what is happening? What will happen if you increasing the temperature? Number of electrons, number of electrons will increase and the resistance will decrease, because we know that alpha of semiconductor is negative, right? So if alpha is negative, then I am having that this won't be my answer, right? This won't be my answer, this won't be my answer. So it will be increasing. Both Ne and resistance will not decrease, Ne will increase, because if we are having more number of electrons, then only the resistance will decrease, right? Simple, a logical question. Now, this question is from 31st January shift 2. This question says that in a typical transistors, all the three reasons. Okay, transistor is now not in the syllabus. So transistors is not in the syllabus. So this question is out of the syllabus. Now this question, 1st February shift 1. This is telling us about the intrinsic semiconductor, N-type semiconductor, P-type semiconductor, and the metals. They are asking you that in intrinsic semiconductor Fermi level, near valence band, Fermi level, inside conduction band, what is actually happening? You have to just find out the correct options, right? So in P type or in the metal is basically what? Metal is a conductor. So in conductor we have discussed that either the valence band and conduction band are overlapping each other, or the energy gap between them is very, very low, right? The energy gap is very, very low, or either they are overlapping with each other. Then what could be the answer? Please let me know. What could be the answer here? Are you there, kids? Fermi level inside the conduction band, because they are overlapping. So this is the option. For intrinsic semiconductor, this will be at the middle. So this will be my option. So now D means fourth. D is all D all are four. Okay, for B and this. Okay, I need to find out one more thing. N type Fermi level near valence band. Okay, now the option number 3 is correct. Let's move. Zener diode, it works as a voltage regulator in reverse bias. Okay, and behaves like simple PN junction diode in forward bias. It works as a voltage regulator in both forward and reverse bias. It works as a voltage regulator only in forward bias. It works as a voltage regulator in forward bias and behaves like a simple PN junction in reverse bias. You tell me that what could be the answer? What could be the answer? The first one. Let's move. Okay, now our January attempt is over. Now it's time for the April attempt. April attempt questions are homework for you. Like always, I just solve one type of questions and the other type will be homework for you. But how we are going to solve this? First, I'll show you. You have to find out the value of net resistance of the network as shown in the given figure. So first of all, you need to find out that whether these are forward bias or reverse bias. If this value is connected with -6 volt and this value is connected with -8 volt, then you tell me that which one of them is at a higher voltage, or if this is a forward bias or a reverse bias. You tell me. -8 is a negative value, right? So this is the positive value. This is forward bias and this is reverse bias. So this will not be in a picture. So I'm having only two things. 15 ohm and 10 ohm. And you can get it 5, 5. Be getting 6 ohm. 6 ohm will be your answer. Okay, because in this condition, this is actually a forward bias and this is a reverse bias. Okay, so you can remove this resistance. You have to take only these resistance. I hope that this thing is clear. And if this thing is clear, we can move towards the last section. This, all these homework, all these questions are homework for you. I'm winding up this video. This video is very, very important. Please do like, share this session with your friend. And if you haven't subscribed to our Telegram, please subscribe that, because that is very, very important, because all the PDFs you will be getting there only. So we'll meet again. Let's, bye bye. My next session will be on atoms and nuclei. So next class will be on Monday. My next class is on Monday at, so do not miss that class. Okay, bye bye. Good night.